This is the only single socket required for the desktop connection, but sometimes we also require the connection or the single socket for the power charging or for the any laptop charging or whatever. So another additional point we required a common point, that is 6 ampere common point or the 6 ampere common socket we required additional to each and every desk. So I will copy this to each and every desk or the partition, office partition, like this. This is the additional power point required for the desk. So what we need to do is to prepare the electrical layout by providing the 6 ampere socket like this in each and every desk. So this is the standard power required, single socket required for the multiple task like charging the laptop, mobile or the other purpose. So I will copy this on each desktop so that it can be seen like this. These are the common point required. So this is the total common point required for the each and every desktop for the single ampere or the 6 ampere socket. Now this is how much? 1, 2, 3, 4. This will be 12, 13, 14, 15, 16 plus this 4, that will be 20. This 2, that will be 22. So total 22 numbers of 6 by 16 socket, or sorry, the 6 ampere socket is there. So it will be the total number is, I will mention the tag number 007, that is 6 ampere common socket required for the power. So that is 22 numbers, and the power requirement, as we calculate the power input for 6 ampere socket, I will calculate it again. That is P is equal to the power required for 6 ampere socket is equal to P is equal to power, V is equal to voltage, then I is equal to ampere or the current required for that socket, and next is cos phi. The cos phi is the power factor required for the single phase. So simply P is equal to 230 into current required, that is 6 ampere, and the cos phi value is 0.8. So ultimately it will come like this, 236 and 0.8. So it will become 230 multiplied by 6 multiplied by 0.8, so around 1.1. So this is the watt. This is the watts required for that 6 ampere socket. So 1.1 is the kilowatt. The answer is 1.1 kilowatt. The voltage will be the same. The frequency, for the frequency, the same frequency we are taking, so that the brake load comes like this. Input power in kilowatt multiplied by quantity, that is 22 quantity, so it will become 24.2. Connected load is more than the brake load, so it will become 29.04. The power factor is 0.8 for the same 6 ampere common socket. The diversity factor will be 0.8, and the multiplication of all this, your operating load in kilovolt is come as a 468.5, and the operating load in kilovolt ampere comes as a 585.6. by this calculation. So I will delete this calculation, and this is the total requirement of kilovolt and kilovolt power in operating load. The next tag number 6008 is there, tag number 00T008, and what is that? For example, this area is the pantry area. I will mention like here the pantry area is there. In a pantry, there is a certain equipment called oven. Oven is always there in a pantry. So here is the oven, and I will mention the oven like this. Here is the oven. And the next is tea vending machine. So tea vending machine is also there, which requires the power point. Tea vending machines require the power point. Oven also require the power point. So I will mention here two numbers. Switch socket like this. This is the 6x16 switch socket for the pantry area. 6x16, two numbers, one for the oven and one for the tea. So this is the requirement of 6x16, two numbers switch socket. I will mention into my electrical load calculation sheet, there is the 6x16 socket for oven. Single phase. Sometimes it requires the 3-phase. Sometimes oven requires the 3-phase connection. Why? Nowadays ovens comes in a single phase, but previously it was in a 3-phase. So here I mentioned only single phase, and the quantity is one number. Power input required for the oven is 3 kilowatt, because the 6x16 maximum power input is the 3 kilowatt. I will mention over here 3 kilowatt. The voltage will be 230. The frequency comes 50 hertz. So directly here is the 0.8 power factor, diversity factor 0.8, operating load, and operating kilovolt ampere. So this is the total power required, 7.2 kilovolt for a single oven. Means for single oven we are giving the 7.2 kilovolt ampere power, kilovolt power. T009 6x16 socket for the tea vending machine. Tea vending machine in a single phase, the quantity is 1 and the power input is also 3 kilovolt. So voltage will be the same, frequency will be the same, power factor will be the same, everything is same. So this is also comes in a same 7.2 kilovolt, and the operating load is in a kilovolt ampere, so that is 9 kilovolt ampere. Here are we completed the some equipments and the electrical power supply requirements. So we can calculate any office or any area, because any office or any areas has the switch and sockets 6x16 amperes, 6 amperes, then the LED downlights as well as the square type LED lights is also there. For each and every equipment we can calculate the multiple power demand calculation. So this is the power demand calculation we have done, and we can done the multiple power requirement. For example, if there is the access door power point required, so we can add the access door power point required in that. And suppose we required a certain power point which is a special power point like 6x16 amperes or maybe 32 amperes power required for a certain area where there is the server room and the other special rooms like panel room is also there, so that we require a 32 ampere switch socket. So we can add the 32 ampere switch socket,